Hi, algebra students. I'm going to go over this Chapter 7 review. So our first example is a house purchased for $226,000 has lost 4% of its value each year for the past 5 years. What is it worth now? So first, let's start by writing our equation. If you're growing by a percentage, then it's something exponential. And so remember, we talked about if you're increasing by a percent, what you're going to do is you're going to convert that percent into a decimal by dividing by 100, so 0.04. And then since you're adding, right, we're losing, right? We lost 4%. It's like we started with 100%, take away 4%, or in other words, 1 minus 4. And so then that's 96%. So if we convert that to a decimal, we get 0.96. The other way you can think of it is the 1% is being 1 minus 0.04 that we found here, which is also 0.96. This is our multiplier. This is our B value. So then we have y equals our A value, which is the amount we start with, right? Whatever amount we start with, that's our A value. So then we have 226,000 times 0.96 to the x power. That's just our general equation. And I'm missing a 0 here. All right, so then if we want to figure out how much it's worth after 5 years, that we're going to plug in here for x, and that will give us our solution. So y equals 226,000 times, oops, my 0 here, times 0.96 to the 5th power. And then you can just put that into your calculator and it will give you your answer. So you should get $184,274.23. Because we're talking about money, we want to make sure that we're rounding to the nearest cent, right? So we wouldn't keep going. It wouldn't be 0.2. We want to go 0.23. All right, so then our next one, it says a 1970 comic book has appreciated at 10%. Appreciated means increase or grow by 10% per year and originally sold for 35 cents. What will it be worth in 2010? So again, if we're increasing or decreasing by a percent, it's y equals A times B to the x power. All right, the A is our starting value. That's our A value. And it increases by 10%. So if it increases by 10%, it's like you had 100% of the value, plus you added 10% of the value. So now it's worth 110% of what it was before. And then if I divide that by 100, it becomes 1.10. That's my B value. That's my multiplier. So my equation would be like the 35 cents times the 1.10 to the x power. So that's my general equation. If now I want to know how much is it worth in 2010, okay, so it started in 1970 at the 35 cents. From 1970 to 2010, that's 40 years. So then I'm going to have y equals 35 times 1.10 to the 40th power. And then you could plug that into your calculator and you get $15.84. Okay, and again, you want to make sure that you are why isn't this getting rid of everything? Sorry. You want to make sure that you are I can't even think about what I'm trying to say now because this is acting weird. You want to make sure that you're rounding to the nearest cent so that, because you're talking about money. All right, I want to scroll this down and it's not letting me, and what in the heck? There we go. All right, I don't know what was happening just there. Sorry about that. Okay, so next we want to write an equation to represent the information in the table. So when I look at this table, I see, okay, well, from here to here, it's going up 400, and from here to here, it's going up 500. So it's not linear, right? Because it's going up different amounts. So then I'm like, well, maybe it's exponential. If it's exponential, that means if I take any term and I divide by the previous term, it should always be the same amount. So if I take 2,000 and divide by 1,600, or 2,500 and divide by 2,000, or even 3,125 divided by 2,500 rather, they should all equal the same amount. And they do. They all equal 1.2. So that means my multiplier is 1.2. So B equals 1.2. Okay, my A value is like your starting value. So that's what's paired with x equals 0. So my A value is 1,600, and it's exponential, which is the form y equals a times b to the x. So then I'd have y equals 1,600 times 1.2 to the x power. And there's my equation. All right, number 4 is the same idea. So I look at this and I say, well, from here to here, I'm going up 30. From here to here, I'm going up way more than 30. So it's definitely not linear. So then I look and see, okay, what's the multiplier? This I can kind of look at and say, oh yeah, 5 times 7 is 35. And then if I do 35 times 7, that's 245. So the multiplier is times 7. If you weren't sure, you could divide like we did up here to confirm that it's 7. Our starting value is what's matched with x equals 0. So then my equation is y equals 5 times 7 to the x power. And that one was a little bit easier to figure out than the first one because you could kind of tell, you could see that 7. All right, so remember also on your test, you'll have stuff from previous chapters, for example, solving a system of equations. So when we go to solve this equation here, I see I've got a y equals, so that makes me want to use substitution. So that makes me think, okay, in this equation, in place of the y, I can now substitute in the x plus 4. And then I'm going to bring down the plus x, and I'm going to bring down the equals 8. And so then I have 2x plus 8, and then plus that x equals 8. These are like terms. So I can say that's a 1x. So I've got 3x plus 8 equals 8. And then when I subtract 8, I get 3x is 0. Sometimes people freak out when this happens and they're like, there's no solution. But if you divide both sides by 3 or think 3 times what is 0, x is 0. And then I can go back with this to get my y value. So y equals 0 plus 4, so y is 4. So then my solution is 0, 4. All right, now example 6 is a little bit different because I don't have it already solved for x or y. So if I wanted to use substitution, I would have to solve one of these equations for x or y. I don't really feel like doing that because I would have to do division. Sometimes that's a pain. I do notice that these y's are almost opposites. And if they were opposites, then I could, like if this was an opposite right here, then I could like eliminate the y's. So to make them opposites, what I'm going to do is I'm going to multiply through by -1. So my top equation here is going to stay the same. It's going to stay 4x minus 4y equals 14. And this equation, when I multiply through by -1, will be -2x, now plus 4y, because the minus and negative becomes addition, and then -8. So these are now opposites. So when I add, I get 2x equals 6. And then when I divide by 2, I get x is 3. And then I'm going to take this x is 3 and put it into either one of my original equations. I think I'll pick the bottom equation just because the numbers are smaller and easier to kind of do in my head. So I have 2 times 3 plus 4y equals 8. So that's 6 plus 4y equals 8. And then I would subtract the 6 and get, I'm going to come up here, 4y equals 4y, I said y but wrote x, equals 2. And then, oops, yeah, that's right, sorry. Having like a moment. Oh, I know what it is. I knew I screwed something up. And you all aren't in the room here to help me, right? This was a minus. I was like, I knew I wasn't getting the right answer is what it was. All right, this was supposed to be a minus 4y. Was anybody shouting? It's supposed to be a negative. All right, so now if I divide by negative 4, I get y equals negative 1/2. So my solution is 3 negative 1/2. Now I know sometimes people freak out when they get fractions for answers because, oh, you must have done something wrong. But if you just take and put it back in, 4 times 3 is 12, minus a 4 times a negative 2 is 2, and then 12, and it ends up being plus 2 is 14. So you can check your answers always to see if you're right, if you're freaking out because you're like, wait, I don't think that's the right answer. All right, so then in 7 and 8, you're asked to write an exponential equation. So sort of like we had to do when we had the tables, but now you're given ordered pairs. So instead of the table, you're given ordered pairs. So you're given that it goes through the point 0, 1.8, and 7, 6,184.75, which you're probably looking at saying, ugh, that's a nasty number. But when we want to write an equation that's exponential, I need the a and the b. And this is my y-intercept, right? When the x is 0, that's your y-intercept. So I know that a is 1.8. So I can put that in here. And I want to find b, so I'm going to put this ordered pair in for x and y. So over here for y, I'm going to put 6,184.75, and then times b to the 7th power. So you don't have to write the complicated system of equations like we had to do in that last lesson of the chapter, because I already know the y-intercept, and in those other ones I didn't. So now we're going to solve the equation. So we would start by dividing by 1.8. And when you divide by 1.8, you end up with, it's like $3,435.90. It's not dollars, sorry, 0.97 equals b to the 7th. And then to get rid of the 7th power, we're going to take, that kind of went over the equal sign a little bit too much. We're going to take the 7th root. So in our calculator, we would do the 7th root of this 3,435.97, and it comes out to be about 3.2. It's like 3.199999. So B is 3.2, A is 1.8. So now into this equation for A and B, we'll have y equals 1.8 times 3.2 to the x power. Now notice when I write my final equation, I am not putting the x and y values into the equation. I just use that to get my b value. Okay, so that's that. And then our last one is the same idea. So again, you're given something of the form 0a. Whenever x is 0, that's always your y-intercept. So I know a is 50, but I have to find my b value. So I would have y equals a times b to the x. Here's my x and y that I'm going to plug in. So 20.48 equals 50 times b to the 4th power. And then we're going to go ahead and solve. So we'll divide by 50. And you're probably like, oh man, I'm going to get some sort of little itty bitty decimal. And you are. So 0.4096 equals b to the 4th. But don't freak out, because when you take the 4th root, not the 4th power, the 4th root of both sides, you end up with b equals a nice friendly 0.8. So now in place of the a and the b, we're going to put in our 50 and our 0.8. So we'll have y equals 50 times 0.8 to the x power. All right, and then my last few examples. Remember, we practiced a lot with exponents, negative exponents. We were talking about more this chapter. So I have a few for you to practice with that. So remember when you have a negative exponent. So I see one like here. What you can do is you can move it to the other side of the fraction bar and then turn it into a positive exponent. So the 5 didn't have a negative exponent, it just stays there, and then it would be times 2 to the positive 3rd. Because you can't have nothing up here, it's like you could think of this as a bin, 1 times 2 to the negative 3rd, so there's still a 1 up there. And so then you have 1 over 5 times 2 to the third. 2 times 2 times 2 is 8. So then that's 1 over 40. Okay, now the next one I notice has parentheses in the -2 on the outside. So now you can think of it as giving that -2 to both things inside. So when I do that, I have 7 to the -2 over 2 to the -2. And I don't want negative exponents. So that moves to the bottom and becomes positive. This moves to the top and becomes positive. So this would now be 4, or so not 4. The answer is 4, actually. I'm just not writing, I didn't write that step in. All right, so it would be 2 to the +2 over 7 to the +2, which would then be 4 over 49. Okay, and then our last one. Again, no negative exponents allowed. I only see a negative exponent on this, so I'm going to move it to the top and make it positive. Everything up here is positive exponents. Like sometimes people see this -3 and they want to move it to the bottom, but the exponent on that is 1. And then also down here, it's like you have a 1. So if you're thinking in terms of a fraction bar, it's like a 1 stays there. You keep your -3x to the 5th and then times 4x to the 3rd. So then that's -3 times x to the 5th times 64 divided by 1. I don't really need that divided by 1. And when I multiply the -3 times the 64, I get -192x to the 5th. All right, remember to come into support if you have any questions.